video, I'm going to show you another scenario of how to solve logarithmic and exponential equations. This scenario is when my bases are not the same. So on the previous example, scenario 1, my bases were the same, so it was really easy to be able to undo whether my variable was an exponent or it was in a logarithmic equation. Here, because my bases aren't the same, when my bases aren't the same, I want to make them the same. And all I do by making them the same is I rewrite them. So if I look at 4 and 2, I want to be able to rewrite those to have the same bases. So I know I can write 4 is a product of 2 squared. I know I'm just going to attach x next to that because that's the same like 2 times x. And on the right side, I know 1/2 would have a base of 2. But the exponent was -1, because remember, whenever you have an exponent of a -1, it's the reciprocal. So then I'm left with x minus 3. So now notice my bases are the same. So I'm in the exact same scenario where I was on the last video. I'm going to multiply both sides by log base 2. So when I multiply this side by log base 2, I have 2 to the 2x, and log base 2 to the 2 to the -1, x minus 3. These are going to cancel out and make 1, so I'm left with 2x equals -1 times x minus 3. A lot of students actually skip writing this step down because they know once my bases are the same, I can just get rid of them by doing the log. So now I'm going to double. I'm going to distribute -x plus 3. So I have 3x equals 3, so x equals 1. So now if I go ahead and I look at the next one, if I look at the next one, 9 and 27, a common base for them would be 3, because 9 is 3 squared times 2x. I'm just rewriting the exponent next to it. 27 is 3 cubed to the x minus 1. So now my bases are the same, so I know when I multiply log base 3 to both sides, I'm just going to be left with 2 times 2x and 3 times x minus 1. So now I have 4x equals 3x minus 1. So x equals -1. Nope, I messed that up. I distributed wrong. Huzzah! It should be -3. So x is -3. In exponential problems, x is allowed to be negative, just not in log problems. So if I go over and I do number 7, 81 and 3, since 3 is a prime number, I know my base probably has to be 3. So remember, when you want the reciprocal, it's just going to be -1. So the right side was pretty easy. The left side, 3 to the 4th power makes 81. So now when I multiply both sides by log base 3, they're going to cancel out. So I'm left with 4 times the quantity of 3 minus x, and -1 times the quantity of 5x minus 6. So I'm left with 12 minus 4x equals -5x plus 6. So I'm going to add 5x to the other side. I get x. I'm going to subtract 12 from 6, and I get -6. So now if you notice, these problems down below, 3 is a prime number, so I can't change 3 to another base. 80, I also cannot change to have a base of 3. So when you're in a situation like this is where you want to multiply, you can multiply by any log. And these are the kinds of problems where you're going to have to be able to use a calculator, unless I didn't want the exact answer. So here I would use the calculator once I get going. But because I can't change my bases to be any numbers, to where they're going to have the same base, I'm going to multiply both sides by any log that I want. Now, I can multiply by just log of base 10. I can multiply by ln, which has base. I can multiply by any one I want. I usually famously either multiply by log or you multiply by ln because you don't have to write a base. So I'm going to multiply both sides by log. So I'm going to have log of 3x and then log of 80. So now I know that properties of logs, an exponent I can rewrite as a coefficient. And if I wanted to solve for x, I would just have to divide by log of 3. So x is going to equal log 80 over log 3. And if I go over to Desmos, which I have to open up, I haven't opened this up yet, Desmos. All right, so we'll get to a window where you can screen. I'm going to type in log of 80 divided by log of 3, and I get 3.98, so let's just 3.99. Okay, so I only do this when my bases were not the same. If I go over and I look at number 9, my bases aren't the same, and I can't change them to be the same. So when you can't change them to be the same, that's where you have to multiply by any log that you want. So I'm going to multiply by log, or you can multiply by ln. It doesn't matter. I always multiply by log because I think it's just the quickest. It really, that's just personal preference. So I'm going to multiply by log on both sides. Remember, exponents make coefficients. I'm going to put it in parentheses because it's both being multiplied. So now this is a little trickier because this problem is easy. I didn't have more than one term as my exponent. I'm going to have to distribute this. So I'm going to have x log of 7 plus log of 7 equals log of 150. So now I'm going to subtract log of 7. So I have x log of 7 equals log 150 minus log 7. And then I'm going to divide by log 7. So I'm lazy. I'm going to type all of that into my calculator, and I'm going to get my answer. So I'm going to come over to Desmos, and I'm going to type in log of 150 minus log of 7. And I got to put extra parentheses in the front and the back, so I can do a big fraction, log of 7. And I get 1.57. Okay? These ones are, I would say, the trickiest. Now, when I have logs and I want to turn them and their bases aren't the same, so log base 2, log base 4, here's where I have to use the change of base formula. So I'm going to just real quickly review what the change of base formula is. So change of base, I'm just going to write it over here. Change of base, if I have log base b of a, I can change that to log of my big number divided by log of my base. And this is equivalent to that. That's what the change of base theorem is. Now, the change of base formula worked when your calculator couldn't evaluate logs with any base other than 10. You would have to use the log of base formula. So nowadays, when I'm just evaluating, it's kind of silly to use it. However, it's important now because when I have a problem like number 10. So number 10, my bases aren't the same. So I'm going to make them be the same. So how I'm going to make them be the same is I'm going to do log of, I'm going to change the big base to the small base. I'm going to change that. Hold on 1 sec. Oh, I'm looking up the wrong problem. So I always change the big base to the little base. So I'm going to do log base 2 of the big term on your log all over log base 2 of the base. And that equals log base 2 of x. Now, over on this formula, I picked log base 10. I could do log base z. It doesn't matter what that base is as long as it's the same, which is why over here I forced it to be the same. So now I'm going to have log base 2 of x and log base 2 of 4x minus 4. Log base 2 of 2 is actually 2 because, if I write it over here, log base 2 of 4 equals question mark. If I change this into exponential notation, question mark has to be 2. So now I'm going to just solve like I normally would. I'm going to multiply both sides by 2. So I have log base 2 log base 2 of x equals log base 2 of 4x minus 4. So now my bases are the same, and I can even make that an exponent if I want. I can cross that out and make it squared if I want. I can now raise both of these to the 2 power, so these are going to cancel out. So I'm left with x squared equals 4x minus 4, and now I can just factor. So I have x minus 2, x minus 2, so x is going to equal 2. And I'm going to plug that in, and I'm going to make sure log stay positive, which it does, so my solution works. So if I go ahead and I do this one more time for you, I always change the bigger number to the smaller number. So my bases aren't the same, so I'm always going to change my bigger number to the smaller number. So I'm going to do this log 4 over log 4. And then the big numbers get written on top, and the base gets written on the bottom. And this equals log 4x. So now I know this just makes 2 because 4 to the question mark equals 16. That's 2. So I know that just equals 2. So I'm going to multiply both sides by 2. So I have log base 4 of x squared. I'm going to make that coefficient an exponent. Log base 4 of 2x plus 15. I'm not going to raise both powers of 4. They're going to cancel out. So if I come over here, I'm left with x squared equals 2x plus 15. So x squared minus 2x minus 15 equals 0. So x minus 5 and x plus 3 equals 0. So x equals 5 and negative 3. And I'm going to go back and I'm going to plug them in, and I'm going to make sure they work. X is not allowed to be negative 3, but x can be.